Well, let's find some derivatives. Let's find some derivatives. We'll start with that. Because integrals are antiderivatives. Let's say y equals 3x plus 2. What's y prime? Let's say y equals 3x plus 4. What's y prime? Another one? Minus 5. Ooh. Still 3? Where c is any constant. What's the derivative? Yes. So what we will be given the derivative, and you guys have to come up with this function. Okay. And again, what about this one? Still 3? All right. So what's the antiderivative of 3? What?
Couldn't it just be like 3x plus c?
And if I just give you guys this, you don't know if it's 2, 4, -5, or 0 or something, or minus 100 million or something like that, right? So we have to just use this c to account for all possibilities, right? So if y prime equals 3, then y would be 3x plus any constant, okay? They would have to give us some kind of initial condition, like y of 1 equals 4 or something like that, and then we could come up with this c value, okay? Cool. What if y prime equals, let's see if we can come up with this, 3x plus 4. What would y equal then? If this is the derivative, what would y equal? What derivative would give you this answer? Okay, so it has to be something x squared, okay. Well, so you're kind of thinking backwards. Okay, we know that the antiderivative or the function will be 1 power more, right? And then you're thinking ahead, okay, if I took the derivative, I drop the 2 down, and then we have to have something to cancel, so we get 3, right? So that's why you're dividing by that power then. Okay, plus what? Plus c, some arbitrary constant that we lost when we took the derivative, right? All right, you guys think you got this, huh? So let's see what's y prime equals 4x cubed minus 2x squared plus 3x plus 5, some random polynomial. If that is y prime or f prime of x or something like that, what would y be then? Okay, so it has to be x to the 4th, then what? So minus x cubed, and then 2 over 3. What happened here? What's the coefficient? What is it supposed to be? There is a coefficient there. It still is 1 then? How'd you get 1? Okay. Plus what? 3 over 2x squared plus c. Cool. You guys see a pattern there at all? Okay, what if, do I want to go here or not? Maybe. Let's just have some fun here. Let's go 3 over 2x cubed plus 4x plus 5. Let's do that. That's y prime, by the way. What would y be? 3/8? So it'd be x to the fourth. And then, so you're adding 1 to the power. Then what are you doing with that power then? Multiplying the front by 4? Huh? 3 over 2 divided by 4. So 3/8. So you're raising the power by 1, and then you're dividing the coefficient by the new power, right? Okay. Plus, now what? Raise the power by 1, divide by the coefficient by the new power, 2, plus what? Plus, this is called the arbitrary constant. We don't know what it is. We'd have to have some type of initial condition. I think you guys see a little bit of a pattern there, huh? Okay, let's get going then. The definition of antiderivative: function f is an antiderivative of f on an interval I if f, capital F prime, x equals f of x for all x in I. What in the world's going on here? So think about this. Capital F is an antiderivative, and you're taking the derivative. So this is the derivative of the antiderivative. They're saying f is the antiderivative if the derivative of the antiderivative is function f. Now, it's going to be a little bit confusing with all these capital F's and lowercase f's now. Some books use them interchangeably, as in one's the derivative, where in another book it's the antiderivative. You'll figure out using context clues. We good? All right, next part. All right, now this is how it relates to the integral, which is also the antiderivative, okay? The antiderivative of lowercase f dx is read with respect to x. That's where this dx comes in. The integral of f of x with respect to x. The antiderivative of f with respect to x. Remember, dx with means respect to. And generally, if we have the antiderivative of f, lowercase, with respect to x, that is equal to capital F of x, which is the antiderivative plus c. Again, if we took the derivative of the antiderivative, you get lowercase f. Couple definitions, couple just explanations, and I think again, with about everything else in mathematics, you do some practice problems, you understand it better. So let's do some of those. Part A. Now guys, what is 3x right here? That is the derivative. This is like y prime. And when we have this integral sign, that means find the antiderivative of this. Well, itself is a derivative, right? Basically speaking. Okay, now how do we find that antiderivative? Okay, remember when I told you y prime equals 3x? You just kind of added 1 to the power, then you divided by that power. Same thing here. Okay, so add 1 to the power, x squared, divide by the new power, 3 over 2. Is that it? Plus c. And this right here, folks, is also called the general solution of the antiderivative. The general solution to the antiderivative. It accounts for all possible antiderivatives. It's all functions whose derivative is 3x. This is all functions whose derivative is 3x. This is like y prime. This is like y. Okay. Part B. Now we have to think about what we did when we found derivatives. We have to rewrite a lot of these functions now. We have to write this in a convenient form so we can apply like this anti-power rule that we're using right now. Okay, so just like before, write this as x to the negative 3 power dx. Okay, add 1 to the power. What do you get? So x to negative 2 power. Now divide 1 by that new power. Then, let's see. Okay, rewrites. We don't have any negative powers. Okay, that'd be 1 over negative 2 is in the bottom already. That means x squared goes in the bottom plus c. If you forget your plus c, it's wrong. I'm sorry. You guys got a handle on this anti-power rule, basically? Add 1 to the new to the power, divide by the new power. Let's do it. Whole bunch of different forms now. Okay, just like before, rewrite this as a power. Okay, that'd be what? X to the 1/2 power dx. Did I forget my dx up here? No, I wrote it. Okay. Okay, antiderivative process. Your base of x, add 1 to the power. That'd be 3/2. And then divide by that new power. You don't divide by fractions, though. You multiply by reciprocal, right? So 2/3. And then plus c. Okay, remember, since the numerator is bigger than the denominator, they could make this 2/3 absolute value x to the 1/2. Remember, we talked about that a long time ago. So just be careful. I hope they leave it as 3/2 power. I want you guys to leave it looking like this, because in the future we're doing something with this, and this is more user friendly than this. Okay, so honestly, I don't want you doing that. Just be knowledgeable that multiple choice questions could manipulate this a little bit. Okay. How about part D? We have a product as the argument of the antiderivative. Guess what we have to do every single time? We have to multiply this out. So you have terms. Okay. Okay, again, this would be like x to the 1/3 power, right? You can rewrite this if you want to, x to the 1/3, and then we get x minus 4, and then dx. Okay, so that'd be antiderivative. X to the, is that 4/3 then? Minus x to the 4x to the 1/3. Use your parentheses and dx. Okay, now we have a base to a power. We have a whole bunch of different terms. Let's find the antiderivative of each term now. Okay, x. Add 1 to this power. Will it be 7/3? And then multiply by the reciprocal, 3/7. Minus. I like to, I won't do that yet. X. Leave a little bit of space for your coefficient. Add 1 to 1/3, that gives you 4/3. Multiply by reciprocal. 4 times 3/4, 4's cancel, gives you 3. Are we done? Plus c. Part E, everybody's favorite. We do not have an anti-quotient rule. We do not have an anti-product rule. We have to rewrite this. Okay, this is definitely a split up problem. X over x to the half plus 1 over x to the half, and then dx. Simplify, antiderivative, parentheses, that'd be x to the half power plus x to the negative half power dx. Okay, now I think we're in a good position to find the antiderivative. Okay, write your base down, add 1 to the power 3/2, multiply by the reciprocal 2/3, plus add 1 to the power 1/2, multiply by the reciprocal 2/1 or just 2, and then plus c. And obviously keep in mind they could rewrite this. We could make a square root sign here if we wanted to. I would say leave it like this though. Okay, part F. Yep, you have to multiply this out. There's no other way to do it. Right now, anyways. Actually, this one you couldn't use any tricks on this one. You have to multiply it out. Okay, squaring this binomial, that would be t to the 4th. 2 times t squared times 1. 1 squared. dt. All right, find the antiderivative. T to the 5th times 1/5 plus t cubed times 2/3 plus d plus c. Well, could we put minus c if we wanted to? Yes, but we don't need that negativity in our life right now. Okay. Minus negative c. Yeah, go ahead. All right, we get in the hang of this a little bit. Yes.
For D, can we solve that one as if it were like a chain rule problem?
Chain rule?
Yeah, can we solve it if that's like how it was written originally?
What do you mean, like?
So you know how like when you like solve like the chain rule, when you take kind of the derivative of the inside and then that will like
For this one?
x minus 4 would be like x minus 4 squared. Can we solve it that way?
No, you couldn't do this on this one. Yeah, you'd have to multiply this one out. Yeah, I wish there were easier ways. There's an anti-chain rule, kind of. It's called the U substitution. It's different, but okay. Basic integration rules. The antiderivative of 0 dx. Well, it would be like 0, whoops. It'd be 0x plus c, right? And so that would be 0, and then so it's just plus c. The antiderivative of 0 is c. If we have a constant, well, we've done that before. It's like, what's the antiderivative of 5? It will be 5x, then plus c. Constant multiplier could go in front. We didn't formally state this or write this, but if we have the antiderivative of multi-terms, we're adding them or subtracting them. It's the same as the antiderivative of each term added together or subtracted. And this is what you guys came up with. It's written weird though, because they put that divide by that new power underneath the x instead of like 1 over it or the constant over that new power. But this is what you were using. So using some of these properties, we can make these problems take incredibly long times, like 3x dx. We could rewrite this as 3 antiderivative of x dx, which is what, 3 times 1/2 x squared, which is 3 over 2x squared. We don't need to do that all the time. We just need to be aware that it could happen. I just want you guys to be able to, oh, what did I forget to do? Plus c plus c. Slow down there. We just got to be able to find the antiderivative really quickly. These are basic properties. We just got to know they exist, be able to use them, be able to identify them, be able to rewrite. Everybody's favorite is next. Guess what it is? Are we good? Need a second? Everybody's favorite. Everybody loves the next ones. No, there aren't any. Proofs? No. Trig. Okay, we have to be knowledgeable of what's happening. We have to see that we have an antiderivative sign or an integral sign. This is an antiderivative of cosine x dx. Whose derivative equals cosine? Okay, sine of x. So you can always check this. What's the derivative of sine? Cosine. If you take the derivative of your antiderivative, do you get the argument to integral? You can always check these. Is it? What's the derivative of sine? Cosine. You're thinking this one. Yeah, antiderivative. We're going backwards. Going backwards. Okay. Whose derivative is sine? Yeah, it's got to be negative cosine. Because what's the derivative of cosine? Negative sine. So you have to have the opposite of that. All right, which one's next? Let's do secant squared. Whose derivative is secant squared? Tangent. Take the derivative of tangent. What do you get? Secant squared. Okay, how about cosecant squared? Is it just cotangent? Negative cotangent. Remember, if the trig function started with a c, the derivative was negative, right? So if the antiderivative starts with a c, it's got to be negative. So that's one thing you can remember. How about this? Whose derivative is secant x tangent x? What did you say? Cosecant? Just secant. Plus c. The derivative of secant is secant tangent. I would highly suggest we make some flashcards or do some Quizlet stuff or quiz your buddies or friends or whatever. Okay, you got to have these in your brain. Okay, whose derivative is cosecant x cotangent x? Negative cosecant x plus c. Those are definitely ones we need to memorize. Let's work on this. Find the general solution. General solution means antiderivative of the differential equation. Differential equation means it is a derivative. Y prime equals 2. I'm going to show you a couple different ways to write this. Maybe I might show you one way, and we'll go with that. All right. So when it says general solution, what does it mean? Find the antiderivative with the plus c. Okay, find the antiderivative with the plus c. That's the general solution. That takes care of all solutions, all possible functions whose derivative is 2. Okay. Now, it's not really good to be able to write it like this. We could, though. antiderivative, take the antiderivative of y prime dx. Y prime is 2. And what's the antiderivative of 2? 2. With respect to x, 2x plus c. If we took the antiderivative with respect to t, it would be 2t plus c, right? That's one way to do it. Okay? We could say this is f of x, right? F prime x equals 2. Then we would say antiderivative f prime x with respect to x, antiderivative 2 dx, and then we'd have our 2x plus c. Okay, that's another formal way of writing this. And here's another. What's another way of writing y prime? Okay, so dy dx equals 2. Now this is the first time we're ever going to do this. We've ever done this, I should say. Let's multiply both sides by dx. And look at where we're at. We can take the antiderivative of both sides. What's the antiderivative of 1 with respect to y? Y plus c, right? But since we're taking the antiderivative of both sides, we only put the c on the right side. Because if you had a c over here, and a c, like c sub 1 over here, and a c sub 2 over here, you moved it over, it'd be like c sub 2 minus c sub 1, which is just another constant, right? Okay, what's the antiderivative of 2 with respect to x? 2x, and then our plus c. Okay, this is one we focus on a little bit more later. Okay, we can do it this way for now. This is called separating variables. Separating variables. We'll get into that more later. All right, let's do a little bit of rewriting and stuff. Just do a couple practice problems, if we will. Go through, rewrite, find the antiderivative, then simplify the antiderivative, if you would, please. Work on these 3 problems, see what you come up with. Then we'll up the ante a little bit and make some more difficult problems. Okay, rewrite the first one. We have antiderivative of what? And then what, dx? Okay, what's the antiderivative then? X to the, what's our new coefficient then? -1 over 2? Let's see, and then we get, we did this one already, right? Next one, rewrite. X to the half. Antiderivative would be then x to the times plus c. And do we really need to simplify this anymore? I think we're good, right? Okay, how about this one? How could we rewrite this one? Yeah, constant multiplier can come out in front. Do we really need to? Debatable. Okay, so 2 times, what is the antiderivative of sine? Negative cosine. Again, we can always check our answer. What's the derivative of negative cosine? Well, derivative of cosine is negative sine times -1, right? Okay, plus c, and then -2 cosine x plus c. We good? Let's skip part A. We just did that one. Let's look at part B, though. Well, that's cosine squared. Okay, so sometimes they're going to give us these ridiculous trig-looking ones. We have to manipulate the argument of the antiderivative so it looks like a form that has an antiderivative. Okay, so first of all, we could break this up as sine of x over cosine x, right? Times cosine x, because you guys are already saying tangent, right? This is tangent, correct? So we have antiderivative tangent times, what's 1 over cosine? Secant. Do we have an antiderivative whose derivative is secant tangent or tangent secant? Doesn't really matter the order. Secant, right? Plus c. So for a lot of these trig ones, you have to rewrite them in a form such that the argument is an antiderivative. So it's a lot of rewriting, guys, isn't it? It's a lot better than the limit process. Could you imagine doing the limit process with this thing? Yeah, good luck. All right, here we go. Now we get into a particular solution also. Find the general solution of if f prime, capital F prime of x equals 1 over x for x greater than 0, and find the particular solution that satisfies the initial condition capital F of 1 equals 0. Okay, finding the general solution means find the antiderivative of capital F prime. What's the antiderivative of capital F prime? What's that going to equal? Capital F. The antiderivative of capital F prime is capital F. We found the derivative of F, would it be? Capital F prime. Okay, so the general solution would be F, and it equals the antiderivative of 1 over x squared dx. Obviously, a rewrite is in need. X to the negative 2 power. Okay, what's the antiderivative of x to the negative 2 power? Okay, x to the, add 1 to your power, and you get negative 1. Divide by negative 1 plus c. Rewrite this so we don't have any negative powers, and capital F of x is equal to negative 1 over x plus c. And this, my friends, is the general solution. Okay, we found the general solution. Now we need to find the particular solution. The particular solution is that one function that has this condition. This helps us find the c value. So when they give us this initial condition, we use this to find c. We use this to find c. That gives us a particular solution. All right, we know what our general solution is. Let's insert our initial condition. So we have f of 1 equals, what would that be? Negative 1 over 1 plus c. 0 equals negative 1 over 1 plus c, because f of 1 is 0, right? And you can skip this step and just put 0 right here if you want to, but since it's the first time we're going over it, I'm showing 0 equals negative 1 plus c. So what does c equal? C equals 1. Now we have our particular solution, f of x equals negative 1 over x plus 1. Solve the differential equation. When they say solve the differential equation, they want the particular solution. Notice they give us f double prime, f prime, and a particular solution here, a initial condition. At the end of the problem, we need to have f of x equals some stuff. Where do we start? Right here. If we find the antiderivative of f double prime of x, what would that equal? F prime. The antiderivative of the second derivative would be the first derivative. Okay, so let's do that. Antiderivative of 3 dx would be 3x plus c, right? And this is what f prime is. We're halfway there. Ms. Molly, can we take the antiderivative of this right now? No. You got to find the particular antiderivative. Okay? Use your initial condition for the derivative to find the actual derivative. Okay? So that would be what? 5 equals 3 times 2 plus c. Because f prime of 2 is 5 when x is 2. Okay? So what would that be? C equals, that's 6. Subtract 6 minus 1. So f prime of x is equal to 3x minus 1. All right, what's the antiderivative of f prime? That would be f. Okay, so antiderivative f prime of x dx equals f of x. Okay, antiderivative of 3x minus 1 dx antiderivative of 3x minus 1. So that'd be x squared times 3 halves minus x plus, and that's what f prime is, right? Or f of x is, right? Okay, now let's use our initial condition for f to solve for this c value. Okay, well, we get 10 equals 3 over 2, 2 squared, minus 2 plus c. Well, that would be 10 equals 12 over 2, which is 6, minus 2 plus c. 6 minus 2 is 4, subtract, and you get 6 equals c. That means our f of x is 3 over 2x squared minus x plus 6. There we go. If you found this derivative, this is what you should get. If you found the derivative again, this is what you should get, right? Questions on this at all?